Good day, Bayos! Welcome to our channel, Bayaw Tutorials. In this video, I am going to solve a problem in Chapter 2, Principles of Hydrostatics from Fundamentals of Fluid Mechanics, 6th edition by Monsoon. So here's our problem. The inverted U-tube manometer contains oil with a specific gravity of 0.9 and water. The pressure differential between pipes A and B is -5 kPa. Determine the differential reading H. So we have a figure here, and before we are going to solve, before we are going to determine the differential reading, we need to identify first the given values of this problem. So we have specific gravity is equals to 0.9. Since we are dealing with water and oil, we have the specific weight of water, which is 9,810 Newton per cubic meter, and to get the specific weight of oil, we need to multiply 0.9 and 9,810. We got 8,829 Newton per cubic meter. Since we have the pressure differential between pipes A and pipe B, we have -5 kPa. It is also equal to -5,000 Pascal as well as -5,000 Newton per meter squared. And since we have a tube here, a manometer tube, we can make an assumption. If the direction is going upward, it is negative, and if it is going downward, it is positive. So now we can start determining the differential reading. Starting here from pressure at point A, from this point to this point, we have the height of 0.2. Negative because the direction is going upward. And from this point up to this point, since the direction is going downward, it is positive. And since we are dealing here with oil, it is the specific weight of oil. Plus because it is going downward again. Since we are dealing here with water, we have the specific weight of water times height, which is 0.3, and the end is the pressure at B. So by transposing the pressure at B from here to here, we get the difference or the pressure differential between pipes A and pipe B minus 9,810 Newton per cubic meter, which is the value of the specific weight of water times 0.2, the height, plus 8,829 Newton per cubic meter, which is the value of the specific weight of oil. Since we don't have any value of H because it is unknown, just leave it, plus 9,810 Newton per cubic meter, since the value of the specific weight of water is 9,810, and 0.3 meters as for the height. So by simplifying this equation, we get, before we simplify this equation, we need to cancel first the same units. And now we have -5,000 Newton per meter squared. It is the value of the pressure difference between pipes A and pipe B, minus 1,962 Newton per meter squared, plus 8,829 Newton per cubic meter times height, plus 1,962 Newton per meter squared equals to 0. And by simplifying again, we got this equation. And Since we are finding or we are determining the differential reading H, we need to multiply both sides by 1 over 8,829 Newton per cubic meter. And cancelling the same units, and after we cancel the same units, we can simplify this equation, and we have H is equals to 0.455 meter. So now we determined the differential reading H is equals to 0.455 meters. So we have the result, or we have the answer, which is H is equals to 0.455 meter. I hope you learned something from this video. Thank you for watching.